Good day, students. Welcome back to DBMS course. And now we are moving to the next chapter with the title of ER and AAR model. In this chapter, we will explore more about the ER and ER model, which includes the introductions of the ER itself and then the basic concept of the ER models. With the basic in places, we'll dive into attributes and then their characteristic and how the ER models shape the entities. And after understanding the attributes, we will try to examine how relationship between the entities are formed, and we will focus on the binary and ternary relationship. And finally, we'll tie everything together by discussing how the constraint map and to control the relationship within the database. So let's start with the introductions to understand the ER and ER concepts. So the first question is, what is the ER model? So the ER model was created by a person named Chen in 1976, and it's a way to visual represent how the data is organized and connected in a system. So it's just like a blueprint for a database. The main part of the ER model includes the entities, its relationship, and the attributes. The entities, it's the main objects or things that we want to keep track of, like student, course, employee, and many more. Meanwhile, for the relationship, this describes how the entities are connected to each other. For example, a student enrolls in a course. So there will be a connection between student and course is the relationship. And the attributes. So the attributes are the details or the characteristic of the entities. For example, a student's name, a course title, or an employee's ID. So why the ER model is so important? Actually, there's no specific way to draw or represent the ER model. The different people might use slightly different symbols or styles, but the basic ideas are the same. So here we are using what is called ER model to help us to think about and plan how the data should be structured before we actually build the database. And one of the reasons the ER model is popular is because it's relatively simple and intuitive to understand. It uses concepts that feel natural, just like in objects with entities, and how they are related to each other is the relationship. There are special tool, the software tool called CASE. It's the computer aided software engineering tools, which is help to create and work with the ER model. And these tools will make it even easier to design and to visualize the databases. So in summary, the ER model, which is introduced by Chen, It's the simple and intuitive way to plan and visualize the structure of the database. It focuses on entities, which is the objects, and then the relationship, which is the connections between the objects, and the attributes, which is about the details of the object. And its ease of use and support from software tools make it popular choice for designing databases. The ER, or entity relationship model, is the visual tool used in designing databases. It helps in creating a clear picture of the data and how different parts of the data are connected. So, imagine you are building a house. Before constructions start, you need a blueprint that shows where everything will go, right? So it's same with the databases. The ER model is like that blueprint, but it's for databases. It helps database designers, the architects, to explain to end user, or we usually call the people we will use the house, how the data or the rooms will be organized and connected. When starting to design a database, the first step is to understand what the database needs to do. And the ER model is used during this initial phase to figure out what kinds of data are needed and how they relate to each other. It's like planning a trip. You decide where to go, what places to visit, and how to get from one place to another before you actually start traveling. The represents a structure and constraint independently of DBMS. So the ER model shows how the data should be organized and the rules for how it can be used. This model is not tied to any specific database software like MySQL or Oracle, and it's universal recipe for a dish. Yeah, just like a universal recipe for a dish. So no matter what kitchen or tool you have, the basic recipe remains the same. So we can conclude that the ER model is the visual plan for how a database should be built. And it helps everyone involved understand the data structure before any actual coding or implementations begin. It is very useful in the early stages of database design and is flexible enough to be used with any database software later on. Introductions of ER model. So in the 1980s, the rise of new database applications like computer-aided manufacturing, or we stand for CAM, or computer-aided design, CAD, computer-aided software engineering, or CASE, digital publishing, the WWW, and telecommunicating applications highlighted the limitations of the basic ER modeling concept. So the ER model was insufficient for these complex applications, leading to the development of the enhanced entity relationship models, or we usually call EER. So the ER model builds on the basic of ER model by incorporating additional semantic concepts such as spatialization, generalization, and categorization. So, in this chapter, we'll cover the basic ER model and then delve into the EER model. Let's move to the next basic concepts of the ER and ER model. The first one is called enterprise. So the enterprise refers to any kind of organizations, for example, university, college, schools, banks, any company. Meanwhile, for the entity, it refers to an object or thing in the real world. So object may be a person, place, or event. As the examples, I have a student of college and schools, loans in banks, employees in company. So that's the examples of the entity. Next is attributes. So these are the characteristic of any entity. For example, a student can be described by his name, age, and then address, height, and class, right? And another examples is loans. So loans can be described by their types such as house loan, car loan, or another loan, iPhone loan maybe, yeah. Another examples is employee in any company can be described by their employee's ID, their name, department, designations, etc. A car also can be described by his color, his model, and then company, etc. And the next one is value. So the value is the information or data which is stored in the attributes of any entity. It's called value. And the all entities having the same attributes make an entity set. So we have the fifth concept of the ER model. It's called entity sets. The next one is domain. So domain or value set is the set of all values or information about any attributes. Okay, now let's take the following slides for your better understanding of the basic concepts, okay? Now let's check this figure. Okay, I'm using okay. Consider the following figure, okay? We have an enterprise. So the enterprise is college where the students are studied. And we have entities, yeah, entity set. Sorry, entity first. Okay, entity. The entity refers to any single student with all the values. Okay, for example, we have 1A1, name John, age 20, brand's computer, first semester, and phone number. Okay. Next, attributes. Yeah, we're talking about the attributes. So the students are described by the registration number, includes name, age, branch, and then semesters and phone number. So these are the attributes of the student. Next one, value. So the values are 1A1 and then the 1A2, 1A3, and then the civil 20 Diraj. Okay, so all of this is called value. Okay, the next one is okay, entity sets. So entity sets represents by the all students. Okay, all students are described by the same sets of the attributes. So all of these students combine together to make an entity set of the student information. So all of this is the entity set. Yeah, we call it student information. Next, domain. Okay, the domain is the value set for attribute. Yeah, for examples. Uh, For examples, we have name John, Gaurav, Vivek, Ami, Diraj, and for age, it's 20, 19, yeah, 22, 20, 21, something like that. Okay, so now you know the difference between enterprise, entity attributes, value, entity sets, and domain. Now let's move on to the next sections. We will understand the characterization of the attributes. So attributes can be characterized by three major types. Simple and composite attributes, a single valued and multi-valued attributes, and derived and stored attributes. We will look into each of them one by one in the next slides. Okay, so simple attributes is a very straightforward, okay? They cannot be broken down into smaller parts. For example, the age of the students. You just have one piece of information, which is the age, right? So the simple attributes means cannot divide it into subparts. Straightforward cannot be broken down into smaller parts. That is simple attributes. Next, the composite attributes. So the composite attributes can be split into smaller or more specific parts. Okay. For example, the name of the student. So instead of just having one name, it can be divided into first, middle, and last name. And each of these is a part of the whole name. Okay, so name of the students can be divided into first name, middle name, and last name. So the attributes, which can be split into smaller or more specific part, is called composite attributes. So we can conclude that the name, which is shown as the composite attributes because it can be broken down into first, middle, and last names, is called the composite attributes, whereas the age is a simple attribute because it stands alone without any support. Okay, move to the next section. Single valued and multi-valued attributes. So single valued attributes is, imagine when you have a student and you want to record their age. So for each student, there is only one age need to write down, right? So this is called a single valued attribute because it only has one value for each person or thing that you are describing. For example, the age of the student. So each student only has one age, okay? Meanwhile, for the multi-value attributes, now let's think about phone numbers students might have. Okay, and some students might have just one phone, but the others might have more than one phone, right? So it's for examples, a mobile phone or a home phone, yeah, something like that. So one attributes can have more than one value for the same person or thing. It's called multi-valued attributes. And the examples is the phone number of the student, because a student might have multiple phone numbers. So that the key difference is single value attributes only one value, like age. Meanwhile, for the multi-valued attributes, because it has the multiple values, just like the phone numbers, yeah. Next one is derived and stored attributes. So derived attributes are those that you can calculate or figure out using other information you already have. For examples, imagine you know the date of birth of an employee and the current date. You will be easily to figure out the employee's age, right? By subtracting the date of birth from the current date. So the age is derived attributes because you can calculate it using the other information. Meanwhile, for the stored attributes, it's the piece of information that just just kept as they are because you cannot figure out from the other data. For examples, the date of birth of an employee. So it's the stored attribute. So it's not something you want to calculate from the other information. You just keep it stored as it is. So that's why we call it stored attributes. So the main difference between these two is derived attributes can be figured out using the other data. Meanwhile, for the stored attributes are kept as they are because they cannot be derived from the other information. We also have what is called null value. So null means nothing or no value. An attribute has a null value when the value is not known. So we don't have the information yet, or the value doesn't apply. It's not relevant for that situation, for example. And the important note is about the null value is the null is not the same as zero. So null is not the same as zero because zero is an actual number, while null means there is no value at all. So it's different. And you can think of null as a blank space, something that hasn't been filled in. So that's different. Okay? It's just like this. This is null and this is zero. It's both of these are different. Okay? The next one is the relationship sets. So we will understand more the type of relationship sets between the entities. Let's go. Before we know what is relationship sets, we need to know what is a relationship. So relationship is a connection between different entities, just like a people, object, or concept. And it shows how these entities are related or connected to each other in a meaningful way. For examples, imagine you have a student and a course. Okay, it's a student and a course relationship. And the act of enrolling is the relationship between the student and the course. And what is the difference between the relationship sets? Relationship set is a group of similar relationship. So it's like a collections of all the same types of the connections between the entities. For examples, you may think about employee working in a different department, and each connection between an employee and an department, for examples like John works in human resources, is a relationship. When we look at such connections together, we call it a relationship set. So in these examples, we have employee and department as the entities, and works in is the relationship set connecting to employee and department. So there is what is called degree relationship sets. So the degree is refers to the numbers of different entity sets that participates in a relationship set. For examples, if there are two entity sets, like employee and department involved in a relationship, the degree of that relationship set is 2. And we have these two type of relationship set. It's called binary and ternary relationship set. Let's discuss each of these types in the next slides. So these diagrams illustrates the works in relationship between employee and department entities. So let's take a look at this figure. The left column, the employee, represents E1, E2, E3, and E4 represents the individual employees. So these are the entities in the employee entity set. And also we have what is called department entity sets. the right column. The eighth circle, yeah, we have D1, D2, and X and more, which is represents different departments. And these are the entities in the department entity set. And in the middle, we have works in relationship set. So the R1, R2, R3, R4 represents specific relationship between the employees and the department. The arrows shows which employees and department. Yeah, for example, E1 is working in a T2, and then E2 working in a D1, and etc. L4 shows the relationship between employee 4 and department 2, something like that. So these diagrams visualize how different employees are connected to department through the works in relationship. Each R, each R in the middle indicates that a specific employee works in a specific department, right? For examples, E1 works in D2, and then, okay, and E3 works in D2, and so on. The works in relationship set is therefore a collection of these individual relationships, which is connecting each employee to the department they work in. The next relationship set is called ternary relationship set. So as we can see in the diagram provided, is represent a ternary relationship set in an entity relationship model. So this model shows how the three entities, which is employee, department, job, are related through a relationship set called works in. Okay, so the employee, which is represents on the left side with instances like E1, E2, E3, E4, and department represented in the top right with the instances like D1, D2. Meanwhile, for the job represented on the bottom right with instances like J1, G2. The works in relationship set is depicted in the middle, which is connecting the employee, department, and job. This relationship is shown as a rectangle with small boxes inside each level, like L1, R2, R3, and R4, and so on. And each small box represents a relationship instance indicating a specific combination of an employee, a department, and a job. And each line from the employee entity to a relationship instances like uh, the R signifies that particular employee is involved in that relationship. And similarly, the lines connecting the relationship instances to the department and job entities shows which department and job are associated with each relationship instances. And we can see from the diagram that indicates each employee works in a specific department and holds specific jobs. And the ternary relationship sets is the three-way of relationship, okay? Because it suggests that the works in relationship depends on all the three entities: employee, department, and job. For examples, as we can see here, the R1 is associated with E1 from the employee entities, and it's connected it to the department of D2 and holds the job of J1. So this type of diagram is often used to model the complex relationship in databases, where the associations between the entities involve more than two entities at a time. Let's now move to the concepts of role and recursive relationship set. Role. So what it means. A role is the part of a function that an entity, like a person, place, or thing, plays in a relationship set. I have a simple example. Think of an employee working in a company in the relationship set between the employee and the department, and the employee's role is that of a worker in the department. Or just like in the real life, you might have different roles in different situations, right? Like being a student at schools and siblings at home, daughters or son at your home, and kind of, yeah. So entities in a relationship sets also have some specific roles. And the recursive relationship set, what does it mean? So recursive relationship set happens when the same entity set appears more than once in the same relationship set, but with a different roles. Let's imagine a person who is both a student and a lecturer at the same college. In this case, the same entity or the same person is involved twice in the relationship set. As a student, which is learning in the class, and as a lecturer, teaching in the classes. And this situation is called recursive relationship because the same entity set, the person, participates in different roles in the same relationship. So, in summary, the role is about what function an entity serves in a relationship. Meanwhile, for the recursive relationship set is when entities plays different roles in the same relationships. Now let's move on to the next section, which is called mapping constraint. So we will focus on the constraints as a rules which the contents of the database must conform. What are constraints? Constraints in a database are rules or a guidelines that ensures the data remains accurate, consistent, and meaningful. And these constraints help maintain the integrity of the data by restricting what can be entered into the database. And some types of the constraints we have mapping cardinalities and participation constraints. So mapping cardinalities, or we usually call it cardinality ratios, it defined one to many. So one entities in one set relate to entities in another set, something like that. And they are like rules that dictate the number of relationships between the two sets. For examples, one to one to many, or many to one, and many to many, which we will talk about it later on. And participation constraints. So participation constraints determines whether all or only some entities in a set must participate in a relationship set. And they define whether an entity's participation in a relationship is mandatory or optional. For examples, if every student must be enrolled in at least one course, the participation constraint for student in the enrolled in relationship is mandatory. So why do you think constraints are important? Why they are important? The constraints will ensure that the data in the database is adheres to business rules or real world rules. For example, if a business rule states that each employee must belong to only one department, we call it a many to one, the constraint would enforce this, will prevent the errors like an employee being assigned to multiple departments. And by setting up these rules, databases can avoid inconsistent, incorrect, and meaningless data, which is ensuring that the information stored remains reliable and useful. Okay, let's move on to the next one, which is we'll look into one by one the type of the constraints. The first one is called mapping cardinalities. So what are mapping cardinalities? Like I just said, mapping cardinalities describe how the entities from one entity set, let's call it X, are related to the entities in another entity set, let's call it Y, through a relationship set. And these are particularly useful for understanding the binary relationship sets, which is about the relationship set between two entity sets. And types of mapping cardinalities includes one-to-one, which is about one entity in X is related to at most one entity in Y, and one entity in Y is related to at most one entity in X. So that's why it's called one-to-one. As the examples, we can say a country can only have one president, and a person can be the president of only one country. One to many. So one entity in X can be related to many entities in Y, but one entity in Y is related to at most one entity in X. Don't worry, I will go into one by one so you will get the idea of what is it about. Example: a manager can oversee many employees, but each employee reports only to one manager. That's one to many relationship. And then many to one. So many to one is many entities in X can be related to one entity in Y, but one entity in Y can be related to many entities in X. For examples, many employees can work on a single project, but each project can have many employees. That's the examples of the many to one. And the last, many to many. So many entities in X can be related to many entities in Y, and vice versa. It's the simple one. For example, a student can enroll in multiple subjects, and each subject can have many students. So many to many relationship. Okay, let's check the diagram for your better understanding. So these diagrams represent 1 to 1 cardinality ratio between two entity sets. Yeah, let's see this X is a country and the president of Y. So entity set X, which is country, each square labeled X1, X2, and X3 represent a different country, and then the president entity set of Y labeled by P1, P2, and P3. It's a one-to-one relationship. So one entity in the first set, country, is associated with exactly one entity in the second set, and vice versa. Okay, that's one-to-one relationship. So each country can have only one president, and each president can serve as a leader of only one country. Yeah, for example, USA only have one president, Canada have one president, which is different, yeah. And Mexico has its own presidents as well. These diagrams illustrates one to many cardinality ratio between these two entities, typically seen in the database designs or the entity relationship diagrams. So we have X, the manager, represents one side of the relationship, and Y, employee, represents the many sides of the relationship. X1 and X2 is the two managers. Meanwhile, Y1 until Y4 are 4 employees. As we can see in the diagram that X1 is related to Y1 and Y4. And this indicates that manager X1 oversees employee Y1 and Y4. And X2 is related to Y2 and Y3, which is indicates manager X2 oversees the employee Y2 and Y3. And this arrow from X to Y indicates that each entity on the X site, which is managers, is associated with one or more entities in the Y site, which is employee. And this is a diagram. A single manager can manage multiple employees, but each employee reports to only one manager. Okay? This is a common scenario in the organizational structures where a manager is responsible for several employees, but each employee typically has only one direct manager. The next diagram is representing a many to one cardinality ratio between these two entities. So X here represents the employee, which is the many sides of the relationship. Meanwhile, for the Y, the projects represents the one side of the relationship. The X1 to X5 is the employee. There are 5 employees, and Y1 and Y2 represent the two projects. Yeah. And the relationship we can see here that X1 and X2, X3, right? And I think, yeah, 4 and X5. Sorry. Let me say it again, okay? So X1, X2, oh no, X1, X3, and X4 are related to Y1, okay? And this indicates that employee X1, X3, and X4 are working on the project Y1. Meanwhile, for the X2 and X5 are related to the Y2 and indicates that the employee of X3 and X5 are working on the project Y2. Okay. And the arrow from X to Y, it indicates that multiple employees are associated with a single project. In this case, each project has multiple employees working on it, but each employee is assigned to only one project. And this type of relationship is common in scenario where a project team is composed of multiple employees, but each employee is dedicated to only one project at a time. The next diagram is illustrating the many to many cardinality ratio between these two entities. So X represents a student and Y represents the subject. So there are two students of X, Y, and X2, and then the subject of Y1 and Y2. X1 is related to Y1 and Y2. X2 is related to Y1 and Y2. So the student of X1 is enrolled in both subject of Y1 and Y2. The student of X2 is also enrolled in both of the subject Y1 and Y2. The arrows between X and Y show that each student enrolls in multiple subject, and each subject can have multiple students enrolled. In this case, both students of X1 and X2 are taking both subject of Y1 and Y2. This type of relationship is common in educational system where the students can enroll in multiple subjects and each subject can be attended by multiple students. Participation constraints. So what are participation constraints? These constraints describe the extent to which entities in an entity set must participate in a relationship set. And I will discuss later on in the chapter 2, part 2. Okay? So, any questions you have? You can send me emails on my Gmails. You know my Gmails, right? Okay, I'll see you in the next video in chapter 2, part 2. Goodbye.